Yes, my name is Maria S Gudjonsdottir and I am a PhD candidate in engineering at the University of Iceland and Reykjavik University. And I'm going to give an introduction about this project, relative probabilities for the two-phase flow in geothermal reservoirs. And generally on the project, this is, like I said, a PhD project that started last year. And it's a collaboration between Reykjavik University and the University of Iceland, and other participants in this project are Keilir Energy Lab and ISOR. And this project is financed by Georg and Landsvirkjun, and Ranís is also financing equipment buying for measurements in this project. Now, to describe two-phase flow in groundwater or geothermal reservoirs, we have the traditional Darcy equation that Snorri Páll mentioned here in one of the earlier presentations today, where we have a description for the flow velocity as a function of several parameters, including the intrinsic permeability, which is the ability of a geothermal reservoir to rock to transmit fluid, and other factors as the flow of fluid viscosity and the pressure gradient and the gravity forces working on the fluids. Now, this equation holds for one-phase flow, and an attempt to develop this for two-phase flow are these equations here, where we have it extended for two-phase flow. And we have now introduced a new parameter called the relative permeability for water and steam, denoted here as Kw and Ks. And they are depending on the water saturation and can be found by measurements. And well, the relative permeability of a phase is an effective proportion of the intrinsic permeability for that phase. That is, it's a proportion, and the value of the relative permeability for each steam is between 0 and 1 for two-phase flow. Now, as you can see in the two equations here, we don't have any factors regarding phase interaction between the two phases. So one might assume that the relative permeability is only linearly depending on the water saturation. But that is not the case according to measurements. Like I said, if there is no interaction between the two phases, we would have the relative permeability for water the same as the saturation, and the relative permeability for steam, that's 1 minus the saturation. But according to measurements, this is not the case. Here I have these two graphs that's showing an example of the results from measurements on relative permeability, where we have we do not have a linearly dependence between the saturation and the relative permeability. The plot says the relative permeability as a function of water saturation. And as you can see, we have an immobile phase until we reach a certain water saturation. That is, the phase do not move until we have reached a certain condition. And yeah, it's definitely not linearly, so there is something wrong with the relation describing the flow. We have here relation more of that the relative permeability is a function of the saturation and power higher than 1. So this clearly shows that there is a contradiction between the theory and the measurements. And like I said, there are some factors lacking in the traditional Darcy relation for the two-phase flow that account for the phase interaction, like buoyancy effect, uplift, and shear forces between the two phases. And well, it can be shown theoretically by solving the equations. That is, the theory doesn't hold for all cases. And since simulation tools used for flow in geothermal reservoirs based on the current flow relation, it is of great importance to improve them. And how are we going to do that? We have to measure the relative permeability and get a new improved relation for the two-phase flow, or an empirical relation that can be used for further simulation tools. And since the experiments that have been made up till now are not detailed enough to make an empirical relation on them, it has to be measured and performed by higher temperatures and pressure. And well, this project then includes making a measurement device to mimic the reservoir condition, which will consist of a steel pipe up to 12-meter high to get as good pressure drop as possible. And we will fill it then with gravel or rock with known absolute or intrinsic permeability. And this steel tube will then be, at the bottom we will insert water in the two-phase zone with the initial pressure up to 100 bar. And along the steam pipe and during the flow we will measure temperature and pressure along the pipe and collect data for this experiment. So the expected outcome of this project are then to measure the relative permeability from this measurement, and we'll use the data to achieve empirical relation for the two-phase flow and improve the current relation, and then use this to improve the currently being used simulation tools. And this will then lead to a better understanding of the flow of the two-phase fluid in a geothermal reservoir. So, that's it. Thank you.
Yes, so I believe we have some time for a few questions. Winnie?
Yeah, I just wanted to ask if you have some ideas or hypothesis of a physical model which you could develop at the same time as you would do these empirical studies.
Yeah, you're meaning which simulation tool we will be improving during this?
No, I'm not talking about simulation tools. Yeah. I'm talking more about if there is some kind of underlying physics which could be explored at the same time you are doing this measurement to somehow model the micro properties here.
Yes, that is the case as well. We will also explore the theory and find a better way to describe the two-phase flow also by that, not only by measurements and improving the simulation tools. We will also go deeper into the theory as well. Any other question? Yeah?
Yes. Do you have any suggestions of why the simple model does not work at all? What is it then? Yeah. Why is the flow so different?
Yes, like I said, there is the factors missing are the interaction between the phases. The current model and the current relation doesn't account for this. Whereas only it's like the phases are flowing in complete.
There are basically two. You split the pore system into two parts.
Two separate channels.
Yes,
yes, so it is like the relation is today. It's considered to be that way, and which is definitely not the case.
So what is it? Phase changes or are there some
interaction shear forces where the steam is grabbing the water with it, and
another question?
Maybe one just about this measurement device.
Yep.
Is this going to be done in laboratory?
Yes.
Control setting with, could you use rock types, different rock types?
Yes.
Yes.
Like I said, the Keilir Energy Lab is a participant in this project, and we will be installing this measurement device at Keilir. And this will then be the steel pipe will be separated in the 2 meters units, so it's easy to disassemble and change the rock material and to play with it.
But you are telling us also that this has never been tested by anyone?
That has been tested, but not at the temperature and pressure is high enough.